G'day, I'm Chris Muir. I'm an Oracle ADF Product Manager working for Oracle Corporation. Welcome to this session of the Oracle Technology Network, OTN's Virtual Developer Day for JDeveloper and the Application Development Framework, or ADF. In this session today with me, you're going to learn about the sophisticated JDeveloper debugging tools and also the Application Development Framework's logging tools that are available to you to assist you to work out when your programs have gone, well, wrong. Hey, we're all human, and it's great to have some tools there to assist us when we do make mistakes. An unfortunate, sometimes frustrating part of being a software developer is that programs that we write, yes, that we write, will have bugs. Those computers, those nasty computers, when we tell them to do things, they do exactly what we tell them to do. And while they may run, well, most of the time, unfortunately, if we tell them to crash or we tell them to do something silly, they will still follow the exact instructions that we gave them. There's no intelligence there. So with that in mind, what we really want as developers is not only great software development tools, but software debugging tools to assist us when, well, we've made mistakes. Remember, to err is human, to really foul things up requires a computer. So, from a developer's perspective, what sort of debugging tools do we want? Well, it's pretty typical that you'll have an integrated development environment, or an IDE, such as Oracle's JDeveloper. And these will provide, the IDEs that is, a number of debugging tools to assist you to work out what your program's doing and why it's going wrong. As you probably already know, a debugger allows you to set a breakpoint, run your program in debug mode, and get to that breakpoint and then start delving through what are the values of the variables, where's the application logic going, and so on and so forth. So debugging tools are very, very important to JDeveloper developers and all developers out there. However, debugging tools from the day-to-day development point of view, well, aren't really good from a production point of view. While we can put breakpoints in the code running on our system, when we put breakpoints in the production system to work out what's going wrong for a particular user, unfortunately it stops the entire system working and all the other users have to sit there going, what's going on today? It doesn't seem to be moving very fast today. So, from a production perspective, we really want something like instrumentation or the ability to add our own logging implementation or logger classes and output. So, in this OTN VDD, Virtual Developer Day session, we're going to look at in three parts really, the JDeveloper debugging tools available within the IDE. We're also going to look at the ADF logger and what instrumentation is available in the framework and you can add yourself. And finally, we're going to look at some of the advanced debugging tools that are available in JDeveloper and admittedly not available in any other IDEs. So you get to see some real power in this little presentation today. So it's pretty typical in a presentation like this, before delving into the tooling and looking at what we can do, first we would define the main concepts themselves. But in discussing debugging to developers, I would say it's pretty safe to bet that developers know what debugging is. It's the hair-tearing, frustrating, what the hell is going on, deadline-killing part of our day-to-day job. It's the act of hunting through your code, following the logic path to try and see where the program has gone awry. Though I must admit, I tend to enjoy the act of debugging. I see myself as a sleuth or a detective whose job is to take some limited facts, then tease out the real issue based on those facts to reveal the real problem underneath. If you like logic games, debugging is something you can have a lot of fun with. A key tool in the developer's repertoire is the IDE, the Integrated Development Environment's debugger. Typically, as you know, a developer places a breakpoint on a line of code, starts the program in a debug mode, and then attempts to exercise the program such that the breakpoint is met, and you can actually investigate what the program is doing from there on, looking at the variables, the logic flow, and so on and so forth. So, in context of Oracle's JDeveloper, let's indeed have a look at that and see what we can do. Okay, what we have here is JDeveloper 12.1.2 running in Oracle Linux. Now, of course, you can run JDeveloper on a Windows machine, a Mac machine, but I'm just choosing to run it on Oracle Linux today. Now, what we have here in 12.1.2 is an application called Summit ADF. Now, from Oracle ADF Product Management, we like to release a number of demonstration applications, and one of the ones we often release is that called Summit ADF, basically showing the capabilities of both JDeveloper and the application development framework. Now, that application is currently running in my Firefox browser, and if you're not familiar with the Summit ADF application, it's basically a stock ordering system for sporting goods from a warehouse. And what we can see here in the main application is, well, we have customers all around the world, and this specific customer ABC company, well, they have a number of orders. But the interesting thing about this application is there's this pop list with 4 values: excellent, good, fair, and poor. And you'll notice that the star indicator is the rating indicator next to it is changing, and we had 3 stars for excellent, 2 stars for good. And that's not what we programmed. I'm pretty sure that excellent was meant to be 4 stars, good was meant to be 3 stars, and so on and so forth. So we've got a bit of a bug there, and that's what we're going to diagnose. Now, before we can actually diagnose this in the debugger, though, is we need to find the piece of code that is responsible. So let's have a look at how JDeveloper can assist us in narrowing down the piece of code where we want to put a breakpoint and run the program in the debugger. So returning to JDeveloper, we can see that the main unbounded task flow has this page called index.jsf. And if I open that, what we can see then is the main contents of the page, but it seems to be a bit grayed out or opaque. Now, the little orange tag there is trying to tell us something. It's saying, hey, that part of the page is actually rendered by a bounded task flow in a region. Okay, so how do we get at that? We navigate across to the right-hand side of that region and we click in it. Notice we get a little pop list or drop down here where we can say then go to bounded task flow. The customer's task flow definition has content in it, and it has a customer's JSF page, which when we double click, okay, there's the source code, but let's click on the design view. Alright, we get to see all the content there. There's the credit rating pop list, and that image tag must be where all the stars are rendered. So I wonder how that works out how many stars to render when we change the pop list. Well, if we right click on that guy and say go to source, okay, here's the source code for this page, drill down a little, so now we can see that there's an image tag which obviously outputs the stars, but that's in an iterator tag, and that iterator must loop over that image tag and put out a number of stars. How does it know how many times to iterate? Well, that comes from the value tag, and the value tag here is mapped to something called backing bean scope, customer backing bean star rating. Okay, so where's that? Right click, go to declaration, customer backing bean, and let me just expand that, and now we can see a method called get star rating. Alright, so that method that one of my colleagues has written must be responsible for outputting the number of stars. So what we want to do now is debug on that method, set up some breakpoints and watch what that actual method does. Now before doing that, I want to show you something that's quite useful. If we right click in this left margin here and tick toggle line numbers, we now can add line numbers to the overall source code. Now that's really useful to do because if you're like me, when debugging a program, often I'll ask a colleague to come across and say, man, I'm looking at this particular method here, I'm not sure what it's doing, can you help me? I think it's that line there that's got the problem. Which line? That line. Which line? Let me put my big greasy finger on the screen. Now I've got fingerprints all over my screen. Instead of doing that by just having the line numbers there, you can say, I think it's that line there that's got the problem, line 48. Line 48. Yeah, okay, maybe that is it. Having the line numbers there, it can really assist you quickly in communicating where problems are. Anyway, returning to the debugging, well, what we want to do from here is we want to set up a breakpoint and the application in debug mode. Now let's do the debug mode thing first. Let's shut down the server, which is currently running a non-debug mode, and just notice the little green arrow here. Now that the server's stopped, let's run the application in debug mode.
And what I like to do is I like to go to the page that we want to run in debug mode, right click and click debug. But you're also free to come up and say, rather than running the application in normal mode, run it in debug mode up here. But let's right click here and go debug. So at this point we need to just wait for the application to restart, the WebLogic server to restart in debug mode. At this point the application is up and running and Firefox is telling us, hey, I've got some more content to show you. And we can see the new tab and the old tab. Just close down the old tab. Now, we've got the new tab running, and now what I want to watch is what happens with the program when I start changing this pop list, see what that get star rating method's doing. And hey, I forgot to add, back in our backing bean, got to add a breakpoint. So how you add a breakpoint is you left click on the margin. Now there are other ways to do it, but that's the easiest way to do it. And what that means is when the program executes and it hits that breakpoint, the debugger will stop at that execution line and ask you for instructions what to do. But at this point, well, the program doesn't have any instructions from the user to run or do anything, so it's just sitting there. So if we return to Firefox and we change that credit rating to good, then you'll see, JDeveloper is saying it wants us to pay attention to it. And now we can see in the actual JDeveloper window that there's this little red arrow there, and that means that effectively the debugger has hit that breakpoint and it's waiting for your instructions. You might also notice next to the breakpoint icon, the little red circle, which has just been shifted to the left, there's a little green arrow, and that also means that that breakpoint has been reached. The other indication that we're now in debug mode is that we have additional buttons available on the toolbar. We have, well, there's the typical terminate button for terminating the session, and in this time, rather than having a little green arrow next to the integrated WebLogic server and the Summer ADF, we've got a little debugger icon just to remind us that we're running in debug mode. Further to that on the toolbar, we have this little red arrow, and from this screen, this little red arrow is not useful, but if we go to, say, the ADFC config file or have multiple other files open and we're currently not quite sure where the current breakpoint or execution point is, if we now click on that little red arrow, it'll take us back to where the current execution line is. So that's very useful in that aspect. Further to that, the next set of buttons here, the next 5 buttons, allow us to control the execution flow. So we have the step over button, we have the step into button, we have the step out of button, step to end of method button, and resume button. And we're going to have a look at what those do, but let's go with the step over button at this stage. Now the step over button is designed to execute one line of code at a time. So let's do that. Let's click it once, and what you can see there is that the JDeveloper has executed line 46, the array list line piece of code, and is now at the if statement ready to execute that. So literally now we can just let the program step on and follow the control logic through our application. So here we can see it evaluating an if statement. Oh, it must have been false. Here we see it evaluating another if statement. Oh, it must have been false because it went to the else. There it's executing a line of code which is going to calculate a value for num rating. Here it's got a for loop. Oh, we can see it iterating through the for loop, and now it's at a return statement. Now, notice as I executed the return statement, we get this little dialog here. Now what this dialog is attempting to say to us is that, hey, JDeveloper is happy to continue showing you the debug output as long as it has source code. Now that method, getStarRating, was called by the ADF framework, and the ADF framework that I have running in JDeveloper here, well, I don't actually have the source code, I have the compile code. So this dialog is saying, hey, I can't find the source code. Now you're free through Oracle support to request the ADF source code from Oracle Corporation, but most customers aren't going to have that, so this is why you hit this dialog. Now you can either say to JDeveloper, well, let me go and find that source code, well, I don't have it. So basically, best option here is say, well, don't ask me about this file again, let's just continue. Now you might notice at this point that JDeveloper is saying, well, what do you want me to do? Okay, well, what I want you to do is continue executing the program just like you normally would. And that's where really this resume button comes into play. If I click this now, this says continue running until you find another breakpoint. Okay, and by chance, we can now see the get star rating method is called twice by JDeveloper. Hey, let's resume again. And now at this point, the program has completed executing its code. And if we return to Firefox, we could see the results and the stars there. So at this point, we've really had our first rudimentary run through with the debugger and seen how we can execute or control the execution lines or the algorithm as it steps through the actual code. And have we worked out what's gone wrong here yet? No, we haven't. So there's certainly something else we need to look at. But you've got the basics of the debugger at this stage. Alright, what I want to do in this little bit then is show you what some of the other buttons do on the toolbar. So we just looked at the step over button, but what about the step into button? What the step into button is designed to do is if you're on a line of code which actually has a function call, rather than just executing that line of code and stepping over it, it will actually go into that actual method and show you what it does. So if you notice on line 47 here, we have a call to get credit rating. So rather than stepping over that line and just getting a result, what we can now do is step into it. And what we see is get credit rating is a method in the same backing bean, and well, it returns something called credit rating. What's get credit rating? Well, we can right click, go to declaration. It's a reference to the select one choice on the screen. Okay, so we return to, oops, you notice how I scrolled down then, I didn't need to do that. I could, for instance, just clicked on the red arrow and it would have taken me straight there. Okay, so, well, we know what that method does. Let's execute it now. We're back to evaluating here and then we can continue on and so forth. Now at this point, well, okay, so we can see that this is going to continue to execute a number of lines. But I've got a sneaking suspicion that this num rating is the secret to the number of stars that are going to be displayed in the with the star icons next to the pop list. So I could step through all the lines of code here and see the result at the end, but what I can also do instead is just click on this option here, step to end a method. And now this will quickly just execute the entire method, and just before the return point we can then see what the results are. Now I haven't showed you how to see the results yet, but that button shows you how it's a really easy way to just quickly skip through all the logic. Now the final button there that we haven't looked at is the step outer method. Rather than the step to the end method then, this would actually return to the calling method that called this get star rating method. Now because I don't have the ADF source code here, we'd hit that same dialog that we saw previously, so it's not particularly useful to us this time. So hey, maybe at this point we've probably got as far as we can go with these execution line buttons. But like I said, okay, so we want to know what the value for num rating is. I think that's pretty pivotal to understanding what's going on here. And beyond the toolbar buttons here, you might have also noticed that a number of other windows became available to us when we were executing in debug mode. Now those windows, we can simply click through them, but just so you know, they're also available via the window option, the debugger options, and you can see numerous windows available to us. And we're going to explain some of them now. The first window that we'd be interested in is the breakpoint window. Now the breakpoint window, it actually gives us a list of all the breakpoints that are actually been set in our application. And JDeveloper does have some, but there's also the one that we created. Now from here we can actually right click and delete that breakpoint, we can disable it, we can even edit it, and as you can see, this particular breakpoint is a source code breakpoint, or basically a breakpoint that will stop at a line of code. But interestingly with breakpoints, we can add conditions to them. So rather than saying to JDeveloper, hey, I want you to break when, I always want you to break when you hit this line of code, maybe we only want to break it when number of ratings equals 3. Okay? So you can put conditions into your breakpoints to make it stop. And this is particularly useful when we're running through, say, a loop that has to run 50 or 100 or 1,000 times, and you know it's only, let's say, on the 33rd iteration where the problem goes wrong, so you could put a condition in there. Further to that, you have other options like what action to take on the breakpoint. So for a source code line breakpoint, we typically hold execution. Alternatively, you could click that off and click on the beep option, and if you imagine you set a breakpoint in the middle of a loop that executes 1,000 times, you could really annoy your colleagues as your program beeps 1,000 times running through the loop. But you know, it's kind of useful. Other things you can do is you can log the breakpoint occurrence to the logs using a tag or expression. Or these options down here I think are particularly useful. You can enable a group of breakpoints or disable a group of breakpoints. Now why would you want to do that? Well, the reason to do this is if you imagine sometimes in a debugging situation you may have actually created numerous breakpoints across your code in different functions, different classes. Now it's only at a certain point when a certain breakpoint is hit do you want all the breakpoints to be turned on. And so by enabling a group of breakpoints here and you give each breakpoint a name, you can say when I hit this particular breakpoint, all those other breakpoints that are disabled, please enable them, and thereafter if I execute or resume executing my application, it will skip to the next breakpoint. It'll be something that is paid attention to, but later on, if we get to another breakpoint where we want to finish that debugging, we can then say disable all the breakpoints that have the same tag, and so on and so forth. So this is a really handy option for basically controlling all breakpoints being enabled or disabled. But I'm not particularly interested in that at this stage. We're just going to stick with the very simple edit source breakpoint. The next window we're going to look at, well, there's really three windows that are related. There's smart data, data, and watches. And data is probably the easiest one to look at first of all. Now what this window here is showing you is all the variables and their values at the current line of code. And there are all sorts of things going on here like the this object, the our object. You can see it's an array list. Yeah, size 2. The number of ratings, 3. Now that's interesting. Didn't we actually, when we clicked the pop list, we changed it from excellent to good? And well, 3 is the number of ratings, so shouldn't we be seeing 3 stars here? We still don't quite know what's going on, but hey, we can now start to see the actual values here. This is pretty valuable. And this gets a little bit more sophisticated than that, because if you ever end up in a situation where you can't seem to get the program to get to a specific value, so in this case the number rating's 3, but we know by chance the program only breaks when it's number 2. We can't seem to get that piece of code to ever get number ratings 2. Well, what we could do here is right click and we can go modify value. Okay, so modify value. Let's actually change the value to 2 and let the program continue to execute as if the value was 2. So this allows you to set up scenarios that for some reason you can't seem to get to by executing the normal application. Somehow the user does get there, you can't, but now you can set up the program with the same values and continue to see what your application does when that value is 2. Now I'm not interested in doing that here, but I thought it was a very useful value feature to show you. Alright, so again, we've got this data window, really valuable, 3, yeah, okay, so what's the smart data and the watches window got to do with this? Well, you'll notice the watches window is null, or has nothing in it, but if we have a wide range of values or variables that we want to look at times the data window can be overwhelming. So what we can do from the data window is right click and say watch, and now that particular value or variable is added to the watches window. Hey, we can watch it from there. And now we don't have so many variables to watch, and that might make the problem set easier to understand. But in addition, the smart data window, well, is very similar to that. What the smart data window does is rather than giving you all the variables in the data window, what it's doing is it's looking +2 lines and +1 line, +2 and -2 lines of the current execution line and saying these are all the variables at play. Okay, so rather than giving you all the variables, it only gives you variables in the sliding window. Now just to prove that, if I go back to the beginning, you notice how here we've got the array list, okay, and we've got the this object. As we step through, now credit rating is involved. We step through a bit further. A whole bunch of variables, and let's go another line, no number of ratings. So the smart data window is particularly useful for just keeping all the values narrowed down a little bit and watching what's going on. Anyway, let's execute the program on, and at this point we still haven't solved the problem. What's going wrong with this algorithm? Well, we still haven't worked out what's going wrong here. So when we've got credit rated at excellent, I expect 4 stars, we got 3, and when I switch to good, I should expect 3 stars, and what's going wrong? We're not sure. Return to JDeveloper, we hit the breakpoint here, but I'm pretty sure this num ratings is the guy that's causing the issue. Now, well, num ratings, okay, there's this for loop down here which goes from I to num ratings, 1 to num ratings, and for good that would be 1 to 3. So let's try and work out what's going on with this for loop. Okay, I'm going to highlight the I variable here and click watch, and you can see, okay, there's I. Now currently we're not at that line of code. Oh, we're still up here. So how do we get from here down to there? Well, we could click all these buttons, or another neat method is you just left click, right click, run the cursor, and now we've actually executed the algorithm above down to this point, and the algorithm is ready to continue waiting for our input. So let's watch. So we're going to step over the first line. Okay, I equals 1. So is 1 less than num rating? It is, so we get 1 star. Okay, now I equals 2. 2 is less than num rating, we get 2 stars. Now, next one, so I goes to 3. There's our problem. That guy there shouldn't be 1, he should be 0. That would give us the right values, then the right number of stars. Great, we've solved it. So at this point we can see just with the general tools here, the general debugging tools, we have quite a set of sophisticated little options for A, working our way through the algorithms, but B, also watching what's happening with the variables. We can modify their values, and this should give us a general indication of what's going wrong. Now, once we've gone through the basic options there, let's look at some of the more little advanced JDeveloper debugging options that we have available to us. What I'd like to demonstrate to you now is a powerful little feature, and that is a exception breakpoint. So you probably had experiences in your applications, your ADF development, where you've hit situations where you get an error like this, a null pointer exception error. Now the reason we're getting this particular exception at the moment is I've gone back into my JDeveloper application. In the get star rating, I've made a slight modification to the actual method that says when the number of ratings returned equals 1, which equates to poor, only in that case set AL back to null, such that when we get down to line 70, AL.add, well, that will cause a null pointer exception. But from your perspective, those exceptions can occur anywhere in your code, and it can be very hard when you first hit one of those exceptions to diagnose what's going wrong. So JDeveloper makes this really easy, because what you can do is, instead of creating a breakpoint at the exact line of code where you know the issue's going on, well, we don't know that, what you can do instead is, in the breakpoints window, come in and add what's called an exception breakpoint. And what you can do now in this particular dialog is say, well, what I want the JDeveloper to do is, if we hit a Java-lang null pointer exception, then break at that particular point. Okay, so that's what I'm doing. I've added that exception here. Let's go back to our application, switch to excellent, switch back to poor, and at this point you can see JDeveloper is signaling to us it wants to take us our attention, and line 70. Like I said, because on line 62 and 63, when num rating equals 1, which equated to poor, we set AL to null. Then on line 70 now we can see AL.add, well, AL's null, and that's what's causing a null pointer exception. And we can see that null pointer exception, or the exception breakpoint, is an exceptionally powerful feature for now for working out where the exceptions are occurring in our application, and thereafter we can make a fix to our code.
So as we can see, JDeveloper has quite some interesting and useful debugging tools in it, but you must admit we seem to be putting the emphasis on you, the developer, to work out what's going on. Is there anything that JDeveloper, or specifically the Application Development Framework, ADF, can do for you to assist you working out what's going on underneath the covers? Well, I want to now discuss, in answering that question, ADF logging. So looking at the instrumentation that the ADF framework has inside it, but also the own logging that you can add to your applications such that you can work out what's going wrong. And this is particularly useful in production situations where you cannot run a debugger with a breakpoint. You can't stop everybody else from using the system while you're debugging the system. So these logs are going to be critical.
So let's have a look how we turn the instrumentation on. Now, first thing to realize is we don't have to have the integrated WebLogic server and the application running in debug mode. This will happily, you can get the ADF instrumentation to happily output its logs during a normal run of the server. Further to that, we don't need to bounce the server and application and apply the settings. Okay, you can basically leave the application up and turn on the logging at runtime, which has great benefits for developers, as they don't have to need to bounce the server, and also in production where not only do you need to bounce the server, but you don't need to kick off users as well. To turn on that logging in JDeveloper, what you do is you come down to the Actions option in the log window and click on the Configure Oracle Diagnostic Logging option. Now, the whole Fusion middleware framework has instrumentation added throughout it, and basically you have a number of different logging classes or logging packages which can produce output. So they could be have a very wide granularity or a very fine granularity depending on what the programmers did in the framework. From our specific interest in Oracle ADF, we can see all the Oracle related ADF related loggers here, and for each one of these you might notice that not only can we come along and pick that option, but we can also say at what level it's going to log. Now this is a tiered system where if we pick severe, only the severe error messages will come out. But if we work our way further down the options here, what will occur as, for instance, if we go for finest, not only will it log all the finest logs out so you can see them, but also finer, fine, config, info, warning, severe. So you need to be a little careful on the options that you pick here because it's a little bit like drinking from a fire hose. You can get overwhelmed with information, and also basically the running application can slow down considerably as it produces those logs. Anyway, with that in mind, still we've got quite a lot of different options here to turn on, and whoops, you can see I've already got one here on previous. So if there are previous options, how do you stop them from logging? You just come in there and you clear them down, and that will stop that particular guy from logging. But questionably with ADF, with all the different parts of our application, how do we get that logging to be turned on? Well, knowing that an ADF application is based on Model View Controller framework, if we just want to get the view layer to output, basically we turn on the Oracle ADF option here to find, and also Oracle ADF internal to find, and that will now output all the instrumentation at the view layer. Separate to that, if we want the controller layer to output, we can come into Oracle ADF and go to Oracle ADF controller, turn that on to find, and in addition we come to Oracle ADF internal and then go to controller and turn that on to find. Or finally, say we want, as example, we want ADF business components to log. Oops, went a little bit too far there. Let's just go back a little bit. So if we want Oracle ADF business components to log, we come down to what's called oracle.jbo and we put that on finest. Now the thing to realize here is JBO stands for Java Business Objects, and that's the original name for ADF business components. That's why we're picking that option here. Alright, so now that we've configured the loggers, we need to do two things. A, we need to get the application to do something so that it will produce logs, and B, we need to look at the actual logs. So to get some logs produced, we'll come back here to the actual running application, we'll expand the Hong Kong option and click on CAM Sporting Goods. Now you notice the screen's reflected the changes here, but you might have noticed it's a little bit slower than normal, and that's again because the logs are being produced in the background. If we go to JDeveloper and we open up the log window, we can now see considerable amount of logs being logged in the logger window. But to be truthful, like I said, that's drinking from a fire hose. It's a lot of information in there. It can be hard to consume. So from the logging XML window, the configuration window, what we can instead do is open the Oracle Diagnostic Log Analyzer. Now what this option does, if we switch to the by log message option, is we can now, for instance, look at all the logs within the last hour. Now I'm not going to be that aggressive. Let's go for the last 2 minutes. click search, and if I just expand this window, you can see all the different logs being created now, and still there's considerable amount of them with lots of different information in there that might be a little bit too hard for us to digest. So something I might be interested in from the Oracle JDeveloper perspective is where all our queries are. So what I'm going to do here is query where the message includes a select, and now we can actually see, oh, there's all our select statements that are actually hitting the database. Okay, so select customer, select order, and so on and so forth. So as you can see, the Oracle Diagnostic Log Analyzer is very useful for getting a lot of additional information from the framework on what it's actually doing under the covers. So let's now consider adding our own instrumentation to our own code, and we'll go back to our favorite little method, getStarRating. Now, up to now, probably the type of instrumentation you've been adding is something along these lines, system.out.println. But in reality, using system.out.println is just not satisfactory for production environments, because the output from system.out.println can be redirected to all sorts of locations rather than log files. So this isn't something we suggest that you do in your applications. Rather, we suggest you create your own ADF logger implementation, and it's really quite easy to do. What we first of all need to do is define our own logger. So here you can see I'm creating an instance variable of type ADF logger called myLogger. And I'm creating an ADF logger. And from a perspective of creating an ADF logger, you can create them all with different names and so on and so forth. You can create them at package level, class level, and I'm going to pick class level today. So I'm going to pick customers backing bean dot class. Okay, and that name, the class name, which includes the package. So the package here is Oracle Summit Backing. The class name is customers backing bean. That will be very important for us to look up the actual logger in the configuration, the ODL configuration screen very soon. So just keep that in mind. From there, we can then, within our methods, include all sorts of logging calls. So if we go mylogger dot, we can see there's a considerable amount of calls that we can be made. And as you can see, we can log at the finer level, the finest level, we can log at the info level, and so on and so forth. Another way to look that up is we go to the navigator menu, we go to the Java dot menu, and we go to ADF logger. Okay, we see that we're using oracle.adf share logging.adf logger, and within that there's all sorts of methods we can make use of. Now there's just far too many to go through here, but what I want to do with this particular method is, okay, well, one of the methods I want to make use of is entering, and this allows me to say, for example, that the user is entering this class and my specific method, okay, and that will be logged for me. Conversely, if we go to the end of this method, we could also do my logger exiting and do very similar code. And so now this will nicely log, this will nicely log for me that the user, by whatever action they've done on the screen, have caused the method to be called, and it's been entered and exited. Now, of course, we probably want more than that. So as we saw previously earlier on in this presentation, the number of rating value is quite important to us. So what about we also add a method to output the number of rating only at info logging level. And again, I'm going to include information about what class is actually raising this logs, the actual method that is being called, and then my specific message, which in this case will be numRating equals, and then I'll just append the numRating integer value that's defined above. Okay, so you're free to go on and add all sorts of different logging implementations. So in this case, I'm logging at info level. I could have called mylogger.severe, mylogger.finest, and even in addition, I can wrap these in if statements to say only if I'm logging at info level should I include additional, actually do the execution of the following code. And there's quite a few best practices that you can think about from the logging perspective. From here I actually need to run my application, so I'll just go back and run it with the logging changes. Okay, so the application is now up and running. We can go to Firefox. The application is currently rendering itself. There we go. I just closed down the last tab. And now we'll go in and change the pop list, which will cause the get star rating method to be called, as we saw from earlier on in the presentation. And if we look at JDeveloper and we look at the logs, we can't see our messages. And that's because, again, we need to go back and turn the actual diagnostics on for that particular class. So if we go to Actions, Configure Oracle Diagnostic Logging. If I come down here to Oracle, I'll actually notice that the configuration screen has picked up that Oracle.Summit backing customers backing bean is actually a logging class, and it's done that at runtime. If you don't see that option and you already had the logging XML file open, what you may need to do is close it down and reopen it, and then it will detect it, because the logging XML file isn't dynamically updated if it's already opened. An alternative option is to come into the plus button and add a transient or persistent logger. Transient logger, basically, it will just allow you to turn on the logging for this session. A persistent logger will be one that's always included in the logging XML file. But I'll take the simple option down to Oracle, down to Summit, backing bean, customers backing bean, and now I'm going to click on Finest. So from then, returning to Mozilla, clicking on the Excellent option, and now if we look at the log windows, we can actually see our specific class logging, entry return with num rating, and alternatively again, we go to the diagnostic log analyzer and click on look by log message for the last 2 minutes and search. Now we can see, well, entry, return, num rating, and so on and so forth. So now we can actually see our logging output specific to our own needs being outputted. So the reason you might want to do this beyond the normal diagnostics in the framework is you get very fine-grained logging which is applicable to your application, and you're not being overwhelmed with all the additional logging and instrumentation the framework has in it.
Alrighty, so now we've looked at the JDeveloper debugger and the ADF logging. Now, I wanted to show you one last thing before we conclude the presentation today. So I want to show you one advanced feature that JDeveloper and the ADF instrumentation brings together to give you some real insight into what the JSF and ADF applications are doing under the covers. Something to look at the actual Java server faces and the ADF lifecycle, which is pretty integral to becoming an advanced ADF programmer. So that feature is called the ADF request logger, and it is a part of the Oracle diagnostic logger that we just looked at. So let's have a little dive in and have a look at that as the last part of the presentation today. To have a look at the ADF request logger, we need to have an application running. So here's Summit ADF once again. Okay, then in JDeveloper, in the Oracle diagnostic logging configuration screen, for the ADF request logger, we need to enable the logger that is Oracle.ADF diagnostic to finest. Now that's essential, you need to do that. From there, to access the ADF request logger or analyzer, you go to the Oracle diagnostic log analyzer, you switch from by log message to by ADF request, and then you query back all the requests within a certain time frame. And I've already cheated here. I've already queried back everything in the last minute. Now what you can see here in reverse chronological order is the requests actually hitting the ADF servlet, I should say, or really the JSF servlet, and being processed by the overall ADF engine. And we see that the very first request took, nearly 10 seconds. That's kind of okay because ADF is really starting up at this point since I've bounced the server, and it's going to take quite a bit of time to do the processing. And in that first request, we can actually see an AJAX request coming in as well, and all the time it's got much smaller. Now what's really cool about the ADF request analyzer is not this display, but the fact then I can then click on one of these, and I'll just expand the screen for you, and then what we can see per request here, okay, so there we can see a request coming into the index page, is we can start to see the JSF lifecycle.
Now you can't see a lot going on at the moment because, well, this is the first time the user has actually accessed a page, and from the JSF lifecycle point of view, it doesn't go through all the phases. But if we go back to the main page of the application, switch to say Brazil, and then go to Unisports, go back to JDeveloper, now do another search on all the requests coming in, let's say in the last 5 minutes now. We can see quite a few more coming in. You can see that the times are getting smaller and faster as the server optimizes and caches information. But if we look at this particular request, now we can see the full JSF lifecycle occurring. And we can see in different parts of the lifecycle it actually doing processing, such as processing the customer's task flow. So with this overall tree or hierarchy, you can even see things like, which bit is taking the most time to process, and maybe we should think about optimizing this phase and finding out why it's taking 467 milliseconds aggregated. It's this region taking 312. Now, admittedly, those time frames are very, very small, so there's probably not a lot to be optimized here. But let me just show you a request that will have a blindingly obvious delay in it, and it might be something you might want to focus on. So if we just return to the running application and we click on the inventory control tab, 1, 2, 3, 4, 5, 6, 7, something really bad going on there. If we go back to JDeveloper, again, we query all the recent requests back, and yeah, that request there taking about 5 seconds. What's going on with that guy? Let's click on him. Well, most of him is running pretty fast, but the render response phase is taking 4.5 seconds. Let's drill down. Yeah, it's all pretty fast, except the inventory control task flow, when it's being processed here, is taking around 4 seconds. Drill down a little bit further. Yeah, it's all pretty fast, except executing the iterator binding for the low stock iterator. That's taking 4 seconds. Right, so the query is only taking 5 milliseconds. Hang on a moment. So there's something wrong with our code where it's attaching the iterator, but not the actual query itself. So that's really useful information there, because it allows us to narrow down at which point in the framework where things are going wrong. It's not the whole page, it's just something to do with that specific iterator, the low stock iterator. And hey, just by chance, I know what I did wrong. Back here in the model project, in the low stock view object, in the low stock view object import, I remember now, in the execute query for collection, I put a sleep in there of 4 seconds. What a silly mistake to make. Now, obviously, your applications, it's not going to be silly mistakes like that, but you are going to have other parts of the application where maybe the database is responding slowly or it's taking a while to render a page. And that Oracle Diagnostic Log Analyzer, the ADF Request Analyzer, is going to give you a lot of information about, in one request, where your application is spending time. So it's an incredibly valuable tool for understanding how your application is performing, and it's also a great tool for understanding how the framework and the JSF lifecycle works, and it's something that advanced ADF programmers can make a lot of use of.
And basically now you've seen that the JDeveloper IDE and the ADF framework have quite a lot of tools to assist you to debug your applications, instrument and log from your applications, and also look under the covers to get some really awesome detail on what the actual framework's doing, where the application is spending its time, and where you can actually focus on fixing your application. So thanks very much for joining us on this Oracle Technology Network Virtual Developer Day presentation. I hope it's been useful to you, and I hope you'll join us again to watch more sessions in future VDDs very, very soon.